Hello everyone, this is Mehul Kumar Bhatt from Group 3. I am here to give the presentation of Machine Learning Assignment 2 for the subject of Business Intelligence to Professor Pedram. So these are the other group members from my presentation is Bright, Ambika, Anshul and Gaganpreet. So this is the report we are going to submit in our assignment submission. We have attached all the screenshots of our code and result for task 1 and task 2. So this is our report, and now we move to the coding part of our presentation. So this is our task 1. So for task 1, we have first of all imported the required libraries of PIL, NumPy, Matplotlib, and sklearn. From sklearn cluster, we have imported k-means. So then we have set the number of cluster to 3 in the k-means. Then we try to load the RGB image of flag of Canada with the help of function of image. And then we convert it in an array. Then we try to identify its height, weight, and channel, as well as we convert it into a two-dimensional array. Then we try to check the shape of the image, that is this value. Also, we try to cluster the image into the list of pixel into 3 cluster with the help of k-min function. Then the fifth function that we have performed is to predict the cluster level of every pixel in the image and plot it back as an image. For that, we have used a label function that is here, which predict and reshape the size as well as image into label and plot it as a label. So here you can all see the image as a label. Then the next function we try to perform is find out the 3 dominant colors in the image. For that, we have coordinate the cluster center with the help of which help us in get 3 dominant colors of pixels into the entire image. It also give us the image size of 100 into 100 into 3 with all pixel as a value as 1. Then we try to identify the first dominant color into the image. For that, we have put all pixel values to first dominant color, which casts the image of np.uint8 after scaling 0 to 255. The reason for doing that is if the color intensity is a float, and then Matplotlib function expects it to range from 0 to 1. If integer, then it expects to 0 to 255. So you can either force all the numbers to integer or scale them all by 1:1 by 255. So here you all can see the gray is the first dominant color. Second is the cayenne is the second dominant color, and the third dominant color we get with the help of plot time show function that is kind of more a brownish black. So this is our task 1. Then I'll try to move to the task 2. So for task 2, the first function we have performed is load the data into a CSV with the help of pandas. Then we try to print out some sample rows, that is 10, and inspect the data sample to identify the dependent and independent variable. So here you all can see we have used the head function and print out 10 rows and all 33 columns. Then the next task we have performed is try to examine the values of each attribute and select a set of attributes only that would affect the prediction of dependent and independent variable. So for that we have used df.column function, which gives us the result like the diagnosis of that function is dependent most of the other columns except unnamed and id function. Then we have split the data between dependent y and independent x variable. For that we have used ilog function, and defined its values. X is the variable for all the independent variables, which are from second to the second last column, and Y is the dependent variable, which is the first column that you all can see. So here column index starts with 0, so first column is of diagnosis. Then determine the data type. We have tried to identify the types of data, that is discrete, continuous, and categorical of each attribute, and encode the dependent variable as it is a string data type using proper encoding scheme. So here three types of value types we try to identify. First is discrete data type. Basically it is info that can only take certain values. Then the categorical data type, it gives us information about the qualities of things. They are observed phenomena, not measured, and so we generally label them with the names. Then we have continuous data type, which is a data that can take any value, usually within certain limits. For that we have performed sklearn model and imported train test split as well as sklearn pre-processing, and we have with that imported label encoder. So here we are converting our text categorical column into a numerical column, and fit transform for label encoder is a two-step process. For first step, we have fit function analysis the column and counts out the number of text categories it contains. And the second step is transform function, which converts the categorical text into numerical data and based on the analysis of fit function. Then the next step we have performed is split the data into train and test data with a ratio of 70% train and 30% test data. We have also don't forget to set a random state to maintain experiment consistency. So here we have set the size of 0.3 test size. Then we have also tried to import sklearn SVM from linear SVC function, and we have further classified to predict output from X test using the already learned patterns, as well as for Y predict it gives us more accuracy. So we got the output of 0.9181 here. Further we again imported confusion matrix from sklearn matrix and print out the confusion matrix. So in that we have got the value of 106, 12, 2 and 51. We again do the same function with the pre-processing in the sklearn library and imported standard scalar. Here we are initializing the scalar function again using ilog function and scalar fit transform function, performing and getting the output as 0.9649. Finally again using the matrix function of Y predict and got the print of confusion matrix as 1053 and 3:60. So this step of 7 is described as, we can see that after using pre-processing on data, accuracy of classifier has been increased. That is because standard scalar standardize the data. This is done so that the variance of the feature are in the same range. If a feature's variance is orders of magnitude more than the variance of other features, that particular feature might dominate other features in the dataset, which is ultimately bad for accuracy. So we should not fit any pre-processing algorithms on the whole data set. We should apply it separately to test set and training set, because the test set is data that you should ideally not even have available while you are selecting, training and optimizing your model. Though it may not affect on test data because we are not modifying the data, we modify the way the data is presented. So we have performed finally the 9 function of hyperparameter tuning with the help of grid search CV and result the train and test data accuracies as well as the best parameters. So here we have imported grid search CV from the sklearn model selection as well as imported NumPy. So we get we are just creating dictionary here I got a total of 13 into 30 is equal to 26 hyperparameters, and which make 13 into 36 is equal to 169 as our hyperparameter search space. So basically we are going to get 116 different combinations we try to search for with the help of this model and refit the estimator using the best found parameters on the whole dataset. So here you can see we have used fitting it into our data and searching for models of all combinations, that is 169. So here you all can see 169 different combinations. We try to print the best parameter with the score of value. So we'll get the best parameter of this with the score of 0.98. So the final answer to the question, step 9, is by using standardization method, variance in data can be minimized and thus we can achieve better accuracy. So it is always a best practice to standardize or normalize data first and then classify it. So this is our concluding our presentation. Thank you so much for listening us. Thank you all of you.